Thank you. Hey, everyone. Yeah, it's been a good 6.5 years at this point with Composer. It's gotten a long way from being this little project we work on for making PHPBB plugins easier to install, which it really has nothing to do with today anymore, to this big, important open source project that most PHP developers rely on for their daily work, that lots of businesses use as a critical piece of infrastructure to run their development work. And to help us figure out how to continue this, because we've been putting huge amounts of work into this. Especially Jordi, who created Composer with me, who's doing most of the maintenance work these days, is working on this at least half of his time, I would say. He's spending like a large amount of his time and not directly getting paid for this. So to kind of combat that, we started what we work on now, private packages, which I would just like everyone to take a look at if you're using Composer as part of your work. It adds some functionality around that that'll help you work with Composer more effectively, that'll combat some of the problems you may run into with dependency management. But today, I kind of want to talk about managing dependencies as such. We always insist on Composer being a dependency management tool rather than a package manager, like not just being this tool that you use to install some piece of software, delete it, kind of update it, but rather to think about dependencies of a project. So to kind of start with that, I just want to take a broader, like a step back, broader look at this. What are dependencies even? And I think you can split this into two key parts. There's services and software. So sure, with Composer, we usually deal with the second part, the software, right? That's how you install some PHP library. That's how you install, let's say, a PHP unit or some other tool that you're using during development that's PHP-based. But it's not limited to PHP. This could be other things. And there's other dependencies, services, APIs that your application consumes, maybe some kind of service that's part of your development process. Like an application has dependencies of various kinds. I mean, obviously, you could go further and even define like the people working on this as dependencies, but this isn't an HR talk, so we'll kind of stick to these things that are kind of related to software. And sure, you could put something in there like external assets or like other data that you're consuming as part of your application that isn't your own. So if those are dependencies, then what is dependency management? And I like to split this into kind of three key parts of what you have to work on. The first one is assembly, which simply means you put together all the different pieces that make up your application. Your application requires some software installed on the operating system it's going to run on, some kind of environment to run in. It requires libraries that it's going to make use of. It requires those services to be up and running that it's going to communicate with. So assembly is kind of this process of putting all these pieces together so that your application gets into the state that it's able to run in. The second one is dependency change management. So here, the change is really the key, where you decide that you want to modify some dependency, replace it, add a new one, remove one. And how do you go about that? What are the processes that you're looking through? And then one that affects the other two kind of is, while you're doing all these things, you're analyzing risks, like the risk of doing this update, the risk of adding this new dependency, and you're trying to reduce them, trying to figure out what's the best library to use, like what's the one that's least likely to break, what's the best solution to a particular situation. So what I'm going to kind of do with you is walk through these different parts of managing dependencies and look at different types of risks that you face and how to resolve those or how to minimize those risks. And like I said before, this may happen at build or at runtime, right? We're both talking about Composer as you're putting together an application that you're then deploying, but also at runtime if you're talking to external services, for example. So let's start with the assembly part. And this is very straightforward. Obviously, running something like a Composer install that will put together the different PHP libraries you're using, that's assembling part of the application. But it means things like installing your web server too, if you're running a server yourself. So that's why apt-get is in there. Or ideally, if you're using some kind of configuration management system like Chef, Puppet, Ansible, Salt, all these, that too is part of assembling your application, the environment that your application is running in. And then for services, it could be things like setting up the authentication to connect to some external API, some kind of glue code that you need to be able to communicate with that API, the client library that you're using to access it. And then at runtime, usually, the actual connection to that service is also part of assembling your application, because as soon as you're using any external services as dependencies, they really are part of your application, even you don't control them yourself. So a key thing that you can see in this assembly step, or like how this has changed over the last years, is that we've gone away from this idea of giving people step-by-step installation instructions, where you have a README, and then you go through, OK, so I have to install Apache, and then I have to install the following Apache module, and then I have to install PHP and the following extensions, but I need to make sure that this PHP extension isn't installed, et cetera. And there's kind of a manual process that people repeat, to these systems that describe a application environment state, and then tools that transform any system into that state. So that is what configuration management tools do, where you define what kind of software do I need installed on my server, what configuration do I need in order to run it. And that very much is what Composer is too. In your Composer JSON, you are describing the state of your application, like which dependencies and which version need to be there in order for the application to run. And then Composer is the tool that'll transform any current state of your dependencies into the state that you're describing there. So it's not a list of instructions of what to install, what to remove, what to update, but rather it describes the state that you would like the application to run in. And the upside of this is that it's much more reproducible. It means that it's easy if you want to deploy something on a number of machines to get the same effect. It's easy to get the same effect in your continuous integration system as it is on your developer machine. Because if you're doing these manual steps, there's always easily a mistake involved somewhere. So then dependency change management. Like I said, the change itself is trivial. It's just the adding, the removing, the replacing, the updating of individual libraries or services that you're using. Like replacing an API is also changing a dependency. You're changing dependencies whenever you run Composer update. And then the management of this change, and I don't mean change management when you'll Google this, you end up on Wikipedia, and it's this complex process. I'm using this in a much more colloquial sense, is to kind of balance the risks of adding this dependency. That where does it come from? Who made it? Can I still rely on this to work from a while from now? If I use some external service, is it going to be available tomorrow? Those types of questions. You think about the consequences this will have, and then you measure what are the costs involved in adding this dependency, integrating with it, versus the advantages. What functionality does it give me that I don't have to build myself? And often enough with dependencies, that's kind of what we are all here for, right? We're using Laravel or lots of other libraries. The benefit is far greater than the cost. But it's important to think about that while you're doing this. But you can also think about architectural decisions that enable this change. Building some kind of abstraction layer that'll later allow you to replace an API or a library more easily, because you're not hard coding calls to it all over your code, right? So change management is also the preparation for any future change, as much as it is the identifying and balancing of risk while you're changing dependencies. So look at some of these risks, like I said. So the first one I want to look at is availability. So examples of this are, I think there was a very famous example last year in the JavaScript world, which I'm sure a lot of you have heard about, where an open source library was deleted. And suddenly, a lot of people couldn't build their applications anymore. Right? So suddenly, this piece of code wasn't available anymore, and it impacted a lot of people. There are some safeguards around this nowadays to make this a little harder. But this is something to keep in mind, to be aware of, that this could potentially happen. Your payment service could become unavailable, right? That's hopefully something you've thought about. If you're building something where people have to pay you, and that's how you're making money. What happens if the service goes away, if it's down for some reason? One favorite of mine is, I don't know if any of you have had to work with this. I mean, like mentioned, I live in Berlin, Germany, which is in the EU, which requires these VAT IDs whenever you're doing a business-to-business transaction to calculate VAT correctly. And this thing, I feel like, is out of service maybe once a week for a couple hours. It's really not very available at all. But you're forced to validate these numbers, so you got to find a way to actually work with that. But like I said, it could be during build time too, right? So something like your Jenkins build server isn't available, right? That's also an issue with assembly of your application. You can't build your tool anymore. So what are ways to reduce this risk of availability? Right? For software, it's really straightforward. If you have a copy of the software, it's available to you, right? There's really not a lot to it. So how do you make sure, let's look at Composer a bit more in like PHP libraries, that you have a copy? So if, let's say, this case of an open source library being deleted happens, where could you find it still? So Composer is a cache, so you could go and try and find it in there, right? If you at some point ran a Composer update install, maybe you still have a copy of it around on the machine where you did that. It's a good way to kind of look for it if the problem is already there. But it's probably not a good idea to rely on that exclusively. Because, I mean, it's a cache directory. It gets deleted. Who knows who actually ran the update with the right version. So good to know about if you're trying to recover something, but at the same time, not something to rely on. I've seen a lot of companies go ahead and fork every single open source dependency they have, meaning they create a repository for each one of the libraries they're using. This will absolutely get the job done. You'll have a copy of every open source dependency you're using. Problem is, as soon as it comes to updating any of these, it becomes a lot more complicated because now you have all of these repositories that are copies of open source software that you're using, and you need to keep them all in sync. So you end up either automating this, building a lot of tools, or doing a lot of manual work every time you want to update any of these things. So it becomes a little complicated, but it's doable. What I would say better alternative is what we do with private packages now, where people have built themselves using Satis, an open source tool that we have for building your own Composer repository, so that you have a copy of all the Composer packages that you're using, because they're run from your own Composer repository. Like private packages will mirror open source packages automatically for you. With Satis, you can configure the individual packages that you're using, and that way you're guaranteed for these packages to remain available. If you look at services, the story is a little different because usually that's provided by some external vendor, and you can't just make a copy of the service, right? It's a service. But you can ask yourself questions about how to interact with it. So can I call this service asynchronously, right? So with my VAT ID check, maybe while the customer's trying to pay for the service they're buying from me, I can save their VAT ID and check it in the background later if the service isn't currently available to check them right now. And then I can get in touch with them, tell them, hey, your VAT ID was incorrect. Can you please update this? We're going to have to reissue an invoice. And that way, I get around this problem that a user is prevented from giving me their money, which they would like to do, just because some external service not under my control is not available. When we were building private packages, we have these workers that initialize packages that need to access GitHub to copy over permissions to look at some of the data. And obviously, we didn't want to rely on the GitHub API to always be available while we respond fast enough during our web requests. So we're doing this in background workers so that our web interface doesn't actually talk to their API at all, ever, so that there's no reliability, like we don't rely on the availability of GitHub just to render our website. But if you do have to do that, think about what's going to happen if it isn't available anymore, right? You're building a site, connects to the API, works great during your testing, it works great while you're using it, but there could be that day where that external service you're relying on is not available. And what will your users actually see? If it's just an unexpected error occurred, they're going to hate you for that. I mean, I really can't stand when I see that error message, which just clearly says that the developer of this software did not think about this problem. They don't care about me experiencing this issue, because they could have gone and actually analyzed what are the problems that could occur here. And then it wouldn't have been an unexpected error, because it really just means that somebody was too lazy to think about what could happen here. So use low timeouts, right? So that the user actually gets some feedback, and then tell them that, hey, this external service currently isn't available. Maybe try again later, or we'll get in touch with you once it works again, depending on what you decided to do there. But do think about these cases. And don't just leave them alone, or sitting there waiting for a page to load and it just doesn't come up is not a great experience. Another type of risk, compatibility. This affects, rather than the assembly process, the change management. Right, so I'm sure we've all seen backward compatibility breaks in library updates. Right, some library is updated, some call I make to it suddenly doesn't work the way it used to work. My application stops working the way that I expected. Same thing can happen with APIs that you're using. Right, I've seen some payment API that stopped supporting credit card tokens, or rather, they turned them into these generic payment tokens because they wanted to start supporting things like Apple Pay and some of these other types of payment. And the calls are still the same to the API because you're still supplying this token, but the meaning has changed. And that can result in, if you're expecting this to represent a credit card and then you make further calls on it, your application breaking, even though there isn't an obvious immediate difference in how the API works. Things you can do about this. Let's start with new dependencies. Right, if you're adding a new dependency, there's some criteria you could go through and look at to decide which one you want to add, if you have a choice between different ones, or even just whether you want to build something yourself or add a new one. So things that I like to look at are, what is the number of maintainers of the library? How many developers are there? Is it being actively developed, or haven't there been any commits in a long time? How many users does it have? Like, it's useful to, on packages.org, you can see installation counts. Don't think about the absolute numbers there, because they're quite meaningless depending on CI, et cetera, that just installs a lot. But it absolutely works just to tell you whether something is being used at all, right? So don't look at the exact numbers too much, but it gives you some information on whether something is actually being used. Now, I don't mean to say that in order for a dependency to be good enough to be installed, it has to meet all of these things. But there are things to look at, right? Sometimes there's a library that's just really small, does a really solid job, and it just hasn't been worked on in a few years because it's perfect as it is. Right? So actively developed isn't on its own a clear criteria. But you can look at all of these things and decide what you want to do. I'm curious, actually, who here has a list something like this that they go through when they add dependencies to a project? All right, that's quite a few people already. That's kind of good. But there's other things. So one thing I intentionally don't list on here is GitHub stars. Because to me, that's a bit more like, when I start something on GitHub, it's something that I'm maybe interested in looking at more. It's not really something that I use a lot right now, so it doesn't really tell you anything about how stable a library is. It just tells you that it's of interest to a lot of people. But then you also need to be thinking about where does the library, for example, get installed from. So packages.org only hosts JSON metadata of packages, right? If you're running a Composer install, the files aren't being downloaded from packages. They're being downloaded from wherever the open source maintainer of this library placed them. Right? Packages.org just collects information on all the versions available, what dependencies they have, et cetera. The Composer then consumes to figure out what to install. But I think something like 97% of the packages on there are actually hosted on GitHub, so it'll go and download a zip file from the GitHub API. GitHub, I think, is probably very reliable and trustworthy, but there could be a library in there that's hosted on some subversion server in the developer's basement. Right? So it's actually worth maybe looking into where does this library come from. Do I trust that to remain available? Going back to the problem we had earlier. Or do I want to make sure that I have another copy of this because it might very well not be available anymore tomorrow? And then once you've kind of gone through this, are there alternatives? Right? Always consider, if this thing stops being maintained, how complex is it? Could I maintain it myself if it came to that? How easy would it be to replace with something else? Are there choices I can make in my own application to prepare myself for that, like these abstraction layers I was mentioning earlier? But yeah, really is one key question I think there is, could I maintain this myself, or could I fix the bugs myself that I may encounter with this library? Or do I have some other kind of plan for who would do that in that case? Now, you have the dependencies and you're trying to update them. And like I was saying, one of the common things is BC breaks. So in the PHP world, I think semantic versioning is quite commonly used at this point. It's this really simple, straightforward versioning scheme where you have 3 digits, X, Y, and Z. You increment Z whenever there's a bug fix, Y whenever there's new features. And X is incremented every single time that there's a BC break. Now, obviously, this is kind of useless if you decide as a developer of a library that, really this time that BC break, it was so small and unimportant, we don't really have to increment X for that. Because you're going to have a user of that library who will rely on just this one thing, and they can no longer trust this promise because you just broke it. And they don't know whether they can upgrade to the next version the next time either, because you may just make that decision again. So the key to using semantic versioning is to really always increment the X whenever there is any BC break. Right? So don't be afraid of incrementing this X number if you're publishing a library. If there's a BC break, at least communicate it clearly to users so they can rely on this promise. It's also only useful if you can answer the question of what is backward compatibility. Right? I mean, there's some things that I imagine that we can all agree on, like if some library deletes a function that used to be there that people might be using, probably a BC break. But what about adding an argument at the end of a function? Easiest answer would be, that's not a BC break, right? I mean, I'm just adding a new argument. It's got a default value. All the previous calls are still going to work. But PHP allows you to pass extra arguments to a function when you're calling it without an error, which means somebody may have accidentally been parsing a value in there, or maybe even for some reason because they have a second version of the function, who knows? So that by adding an argument, suddenly the call changes because they're passing in that value already, which was previously ignored. I don't know what the right answer to that one is, but at least as the developer of the library, you should be giving a clear statement on whether you think that is a BC break or not. So I think there's a great example of this that the Symfony framework does at this URL, where they define very clearly what they promise with these X increments in the semantic versioning and what they don't promise. So that at least as a developer using this library, you know whether you can trust them to remain compatible once you do an update, or whether it's something you're going to have to manually review. So as you're using this library, you have a better understanding of what you can and cannot use if you want to be able to update easily. So if you're working on an open source library, either just adapt this thing, just take it over, maybe write your own, but do clearly communicate what you mean by BC breaks if you're using semantic versioning, because otherwise there's no purpose to using semantic versioning in the first place. Now, as a user of a library, the caret operator in Composer is for the semantic versioning because it'll upgrade to anything without a BC break. But if you know that a library either doesn't consistently follow this, or that you're using a part of the library that is documented to not be considered a BC break if it changes, you could use more narrow version constraints, like the tilde operator, which will only increment the last digit, so that you will have to manually modify the version or upgrade the version after you've reviewed the code to still work. There's lots of other ways to help you work through compatibility issues. Obviously, your tests, right? You run an update, run your tests, you know whether things break or not. You can do things like static analysis. There's a tool called fan that'll help you figure out things like, oh, I'm making a call to a function here with the wrong number of arguments, or that might only otherwise show themselves at runtime. There's manual things too, like actually reading changelogs. Like who here reads all the changelogs of libraries they use whenever they update them? It's a really sadly small number. But I mean, part of the problem is if you're working on a library for others to use, actually write a changelog, because nobody can read them if they're not there in the first place. And by that, I mostly mean document clearly what these BC breaks are. right? I mean, sure, you can write a gigantic list of like all these things have kind of changed. But what's important to a user of a library are the things that they need to know in order to upgrade. Has anything changed that will modify the behavior for my application? Is there any big breaking change that I need to know about? And then, like I said, kind of experience, right? If you know a library often breaks backward compatibility with minor updates, just constrain it a little more. Don't look at it more closely when updating. Oops, apologies. All right, so I'm talking about updates, so let's actually look at Composer a bit more. The typical, common, easy way that people learn to update dependencies with Composer is to run Composer update. Composer update will go and update everything. And you might be familiar with this from tests, that you want to write more isolated tests so that you know if something goes wrong, where it went wrong. And in the same way, I would argue that if you want to update dependencies, either you run the Composer update every day or at least every couple days, so that it only updates a couple libraries because you're doing it so often. But in reality, often that's infeasible. Sometimes you're working on a project that nobody's touched for a year. Maybe you're taking this over from someone who just hasn't been doing this. There's lots of reasons why updates haven't been run for quite a while. So then a good bit is to actually only update specific packages one at a time so that you can run your tests in between. And then if something breaks, you know which update actually caused the problem. And to help you with that, you can use this dry run option for Composer, which rather than actually doing the update, will simply output what it would do if you were to run an update right now. So you can run a Composer dry run update. It'll tell you all the things that would need to be updated. And then you can individually update them and test in between to make sure that something still works. It's really helpful to kind of also, if you want to actually look at changelogs, do the dry run first, and then you know which libraries to go look at the changelogs and what version they would be upgraded to. So I'm saying that you should do this Composer update and then one particular package. So I want to kind of look at how that works. So I made up this absolutely absurd example of a zebra that depends on a horse, a giraffe that depends on a duck, the horse that depends on the giraffe, the duck doesn't have any dependencies, and I have a project that uses the zebra and the giraffe. So as a graph, so that you can actually understand this. Right, I have my project up there. I use these 4 different libraries that have relationships to each other in version 1.0. And now all of these packages release a version 1.1. So as a first step, I'm going to run just the update on Zebra, which will tell me it will upgrade Zebra from 1.0 to 1.1. Really straightforward. Problem with that is, now I would have to actually go through every dependency of every dependency to eventually update each one by themselves, which is in a bigger project, way too much work to actually go through. So Composer has this helpful flag. It's called with dependencies. So you'll only do this for the dependencies that are direct dependencies in your own Composer JSON. And then once you update one of them, you update all of their dependencies. So it'll go to Zebra 1.1, update that, go to its dependencies, horse 1.1, update that, go to its dependencies, giraffe. Oh, there it actually stops. So the assumption that Composer makes here is that anything that you specify in your Composer JSON is something that's a direct dependency of your project and something that you want to be managing. That's the reason why things like stabilities in Composer, if you use like this at beta or at dev or minimum stabilities, are only work on the root level of the project rather than being transferred in through dependencies, is that what's in the Composer JSON is under your control of the project. So to upgrade Giraffe 2, you would have to update both of those. Or rather, because we're trying to do with the dependencies, add the with dependencies, and then it would update all 4 of them. Right? So you have to do this for each direct dependency of your project, but not for the ones that they depend on. All right, so you've done the update. What the update does mostly, it modifies the log file. And just as a recap, I hope that a lot of you have an idea of what the log file is. It contains a list of all dependencies, including these transitive dependencies of dependencies, et cetera. It contains an exact version number for each one of them, not one of these constraints that contains an asterisk, but rather the exact number that you've installed. It contains download URLs. So that URL from GitHub that you're about to download the zip file from, or the repository URL to clone from. Or mirrors if you're doing the private packages mirroring of your open source dependencies. And hashes of the files that are to be installed. And the purpose of the log file is that you can reproduce the exact same state. Remember the beginning of this talk, right? We're talking about a state that the application runs in on different machines in a team that you're working with, on the machines of users that you're shipping an application to, on your CI system, on different servers that you're deploying this to. And you're certain that they will all get the exact same version, even though maybe between me installing this on my machine and my colleague installing it a week later, a new version of something was released that would have matched my constraint. This makes the process of updating a lot more explicit, because you're actually documenting whenever you update, your colleagues see that there's an update that somebody performed. It also helps you isolate the cause of bug reports, right? So you know that the user of your application was using the exact same versions, and the bug that they're experiencing is actually in my software that I shipped to them, rather than a result of a dependency update. And this is why it's so important that you commit the log file into your version control system, because otherwise you don't get any of this. Composer install without a log file is actually a Composer update. Like, I'm hoping that maybe in a future version of Composer, maybe Composer version 2, we can actually make Composer install without a log file result in an error. Because you're not doing an install if you don't have a log file, you're doing an update. The consequences of this, this affects this assembly process again, because conflicts between dependencies could randomly occur while you're running a Composer install without a log file, because you're actually currently updating and not installing. You may not end up getting the same code that the person who previously ran this got, right? So your deploy may end up with a different version of some dependency than you yourself. So you're really not managing the change anymore if you're not committing the log file. It's like the change is just managing you, right? This is the whole purpose of the log file, is for it to be committed. Now, once you do that, who here has run into a merge conflict with a log file before? Yeah, so this is kind of a common problem, right? I'm telling you all this, but then you run into this problem. That's why people stop committing the log file, but that's really not the right solution. So the Composer log file cannot be merged without conflicts, and that's quite intentional. And I'll tell you after this why that is, but let's look at how to fix one of these merge conflicts first. So what you need to do is you need to check out the log file of the base branch first to get the state of whatever the other person changed. And then you need to rerun your updates. You do that with git checkout and then the branch that you work on. So maybe if the master branch has deviated, you'll take the log file from there, and then you rerun the update in the same way that you previously did. Now, in order to do that, if you're using the partial updates like I was describing, you have to actually know which packages you were updating before. So it's useful to store the parameters you're using for Composer update in a commit message while you were doing those updates, so that you can later reference this and then rerun the same command, which also means it's useful to have a separate commit for every time that you update dependencies that doesn't change anything else, simply so that this is isolated in one place and it's easy to reproduce later on. Now, why do I say that it's impossible to merge the log file? Let's take an example. This is kind of my previous project with the ridiculous names. We have one branch on the left, one branch on the right. On the left, somebody runs an update of Zebra, which introduces a new dependency on Duck 1.0. 2 weeks later, in my branch that was based off of the original state, I run an update on Giraffe to 1.2, which depends on Duck 2.0 now, because Duck 2.0 was released between these 2 points in time, right? There's 2 weeks difference in between somebody released Duck 2.0. So I got Duck 2.0 in my branch. Now, the log files of these two states are going to conflict. If I was going to go ahead and just merge these on a text basis, like what Git would do, for example, I would end up with the thing on the left, right? Because the log file just contains an entry for every dependency. So there would be one entry for Duck 1.0, one entry for Duck 2.0, and these would just be in the same file. This doesn't work in PHP. You can't have the same class name 2 times. Right? So the state on the left is invalid. So instead, you do have to take the same basis again that contains the Zebra 1.1 from the other person and rerun your own update of Giraffe 1.2, which will then install Duck 2.0 just as before, but it'll check that Zebra 1.1 is actually compatible with that version 2, and it'll be fine. If it wasn't, it would give you an error at that point, and you would actually have to do something. That's why it's so important that you actually rerun the update rather than trying to manually merge those files, because you may end up with these invalid states. Another type of risk that you could look at, something that as developers we often like to ignore a little bit, like compliance legal issues. They too affect change management. So with software itself, that's usually, or most commonly, I think, viral copyleft licenses. So if you're shipping code to a customer under certain licenses, are you allowed to include GPL code or not? Something you got to work out within your company. But at least it's something to think about and to consider. So if you're adding a new dependency, talk to whoever else is in your business who's making these types of decisions. Think about this. And I think even more importantly, with terms of service for external services you're using, you should review, may you actually use the API for what you're trying to do. So there's like one example I like to use for this is with packages.org, where we get asked, why doesn't this just run through Cloudflare? There's some technical limitations due to the speed of how frequently packages are updated that prevent us using a CDN in that way. But there's also something about the Cloudflare terms of service that specifically say it may only be used for HTML content. And we're shipping JSON there. So while it may very well work right now, based on those terms of service, they could turn this off any day and nobody would be able to use packages anymore because we built this in there. So it's something to actually look through. What do those terms of service say when you're just starting to use some new API, and to actually consider the details there. How much time do you have if a supplier decides to terminate an API? Is that enough time for you to transition to some different service? Can I replace it in that time? Think about that before you start using the service. Do they offer an SLA with sufficient support? If my business critically depends on this API, maybe I do want to be spending a bit of money on actually getting support if things go wrong. It's always great as long as everything just runs, but do consider the possibility that one day something may break. Right? So ways to deal with this. On the software side, Composer offers a command called Composer licenses that will actually display all the licenses of dependencies that you're using so that you can easily review them and make sure that they follow the rules that you have to follow within your business. You're using private packages. It has a thing called license review that does very much the same thing, but across the entire organization, all the different projects that you have. And with terms of service, you can use this as a criteria for the selection. But I think more importantly, you should remember that those are often negotiable. Right? We're living in a time where if we sign up for a service, we check the terms of service and then click the purchase button. But often enough, it's as easy as sending the owner of the service an email and asking whether they can't add this one line for you that states that you would also be allowed to serve JSON through this API, for example, right, with the cloud, for example. So it's important to keep in mind that even though for the ease of signing up, et cetera, it's often just a checkbox, it's easy to negotiate terms when you're using a third-party API. And it might actually make sense to do that once in a while. And then if they are so critical to your business, those dependencies may actually justify that you spend some money on them, right? To make sure that your business continues to operate. If you're critically dependent on this one open source service over there, this open source library or some service, maybe it's worth spending some developer time on helping that library, on fixing bugs in there. Maybe it's worth funding that project in some way. So I think what I'm trying to say here is mostly formulate a plan B, right? Think about these types of risks as you're using dependencies, as you're working with them. And it's perfectly fine for you to say, hey, I'm like a small new business. I'm just building this project over here. It's a waste of time for me to build an abstraction layer to potentially one day replace my payment API, because I think it is a waste of time. But at least you once consciously decided not to do that. So you know when it happens that what you have to do, right? So just have a plan ready for what would I do once that day comes. And then identify the problems that actually have probable great effects on your business so that you don't end up building abstraction layers for things that are unlikely to ever become a problem. One thing that I like to compare this to is like, who here has ever migrated a project from MySQL to PostgreSQL? It's a couple people. Who of you was able to do so without changing any of the code? Right? So database abstraction layers are fantastic for reasons like easy transitioning between projects, right? You'll learn how to interact with the database, and it makes it easy for a developer to get onto a new project. But they're not there to make this transition super easy, right? So you have to focus on what is my problem that's going to have an effect on my business. And sure, getting new developers onboarded quickly might be a big problem, so that's maybe why I want to have that debug. But switching from one database to another, how likely is that actually going to be? And is that even going to help? So at the same time, what I'm not trying to tell you is not to use dependencies, right? They're great. Again, this is why we're here. They save you a ton of time and money. What I'm trying to tell you is that you should look at which of those actually pose some amount of risk to you and then work on just reducing those risks to an acceptable level as a business. So in a summary, use composer update with dry run to get an idea of what's going to be updated. Do partial updates. Use this git checkout branch composer lock to reset the composer lock to then reply the update on. Formalize your BC promises for users of your libraries so that they can actually rely on semantic versioning. And then do not be afraid of incrementing the first version number on a library that you're publishing. It's OK to have large numbers there. And then document changes to dependencies. Document them in the form of changelogs on libraries. Document them in commit messages so that other developers on your team know what you were doing. Formulate a plan B for any of these risks involved in dependency management. But also don't waste resources on potential problems that are unlikely to occur and have insignificant effects. Right? Don't spend way too much time on building yet another layer between another layer for some problem that is unlikely to ever exist in the first place. And then again, dependencies are great. Go out there, look on packages.org. Most likely somebody has already solved some of the programming problems that you're facing. Use those. Their benefit is usually significantly greater than the cost that comes with managing them. So I think my message here is a bit that developers need to consider these different aspects of dependency management from a business perspective sometimes. They need to consider how much time does something take them, how much is that worth to the business. Developer salaries aren't that cheap. And that's something developers often forget, and then they go off on this project for a week of building this fantastic, great new library that solves all the things that they ever dreamed of. But it doesn't actually bring any value to the company that they're working for. But at the same time, if you're more working on the business management side of it, then you should be looking at dependencies not as this thing that developers just kind of use and you can ignore, but rather as a key part of your business. You should understand what the risks involved are, and you should see them as an investment you should invest in them if you depend on them so much. So with that, thank you very much for coming today.